Welcome to Year 2 Pure Maths, Chapter 4.2, where we continue to look at binomial expansion with a fractional or negative power. So in the previous lesson, 4.1, we talk about a new formula about using binomial expansion when the power is fractional negative, which is 1 plus nx times n minus 1, 2 factorial, x squared plus n times n minus 1 times n minus 2 over 3 factorial times x cubed. If you're interested in how these coefficients are derived, you can go back to chapter 4.1 video. Right, so this also given a formula booklet. This version of the equation is given a formula booklet. So let me. Okay, so you can see a plus bx to the power of n. Now we're not going to copy this one because what we're going to do is this not actually not quite helpful in the solution bank. What we're going to do is we're going to write down the to use this to use what we learned in 4.1. What we can do is we can factorize a first. Now this step is quite important, right? So we're going to factorize the a inside the bracket. So the power of n is still outside. So factorize a becomes 1 plus b over ax. Okay, so everything happening inside the square bracket, the n, everything happening inside the power of n. And then now if we want to take the a out, we can do a to the power of n times, okay, 1 plus b over x to the power of n, b over a. Right, now very, very, very important. Students very often make mistake in this step. Trust me. Yes, that's the source. Trust me. How do I know? Trust me. For a plus bx to the power of n to be valid when n is negative or fractional, we can do, oops. So we know a plus bx to the power of n is the same as a to the power of n, 1 plus b over ax to the power of n, right? And we talked about the validity last lesson. That's not when I recorded the last video. Definitely not. It's b over ax. So what we'll do is in here, so valid when the x term, which is now b over ax, is less than 1. What does that mean? That means if we take the b over a out, factorize it, then we have a over b. Again, something you can remember. It's a 1 mark or 2 mark. You can just write the result. You can just write it down. Right? Right. So, example, find the first 4 terms of the binomial expansion and state the validity. So I'll do part A. Maybe we can do part B. Okay, so I'll show you part A. So part A. So 4 plus x to the power of a half. Now, this number here is not 1. So what we'll do is, I'll show you. So let me do note. So what we'll do is we'll factorize the 4 out. So a to the power of n factorize 4 out. And then 1 plus x over 4 to the power of a half. If you're struggling with this, let me show you the steps in between, whether you want to copy it or not. So 1 with a square bracket, okay, factorize a 4, so 1 plus x over 4 to the power of n, and not put I, power of a half. And then I put a half back into the bracket, 4 to the power of half, times 1 plus x over 4 to the power of a half. Happy? Right, so 4 to the power of half is the same as 2, root 4. So it will be 2, so that's the same as 2 times 1 plus x over 4 to the power of a half. And that's when we need the binomial expansion. So I'm going to rewrite this as 2 times 1 over x over 4 to the power of a half, roughly equals. That's when we start to use binomial expansion. So we need to make the front number 1 before using the formula. Okay, so very important. So which roughly equals to 2 times, okay, so I'm going to do the binomial expansion inside. So it's 2 outside times. So 1 plus nx. Let me copy down from last time. I just realized, sorry, I just disappointed you. Actually, this is actually given in the formula booklet. So the 1 plus x to the power of n is actually given in the formula booklet. So 1 plus nx, so n is a half. So right in here, by the way, so x is x over 4, n is a half. Okay, 1 plus nx plus the first 4 terms times n minus 1 over 1 times 2 times x squared, so x over 4 squared plus n times n minus 1 times n minus 2 over 3 factorial, so which is 3 factorial times x over 4 cubed plus dot dot dot. So that roughly equals to 2 times, so put in a calculator one by one, so 1 plus x over 8. And then the next one will be 1 over 128 x squared, and then 1 over 1024 x cubed plus dot dot dot. Don't forget to multiply 2 back in. Now you might be asking, what's the difference between a square bracket and a round bracket? You might be asking. It's just telling you a different set of brackets. Usually when we open a round bracket with close round bracket, a square bracket essentially means it's just a set of bracket outside a round bracket. It's like a layer of brackets. You have to get rid of the outside inside. So they basically it's like a small bubble and a bigger bubble. Um, that's how I was taught when I was a kid. If you want to open a bracket that contains a round bracket, you have to do a square bracket. If you want to contain a square bracket, you have to do a curly bracket. That's how I was learned. Anyway, so if we multiply 2 back in, but they're essentially just bracket. So 2 times 1 is 2. 2 times x over 8 is x over 4 minus 1 over 64 x squared plus 1 over 512 x cubed plus dot dot dot. Okay, that's expansion. Right? So if you're happy with this, your turn. Part B. Okay, part B, I'm going to set you up. So part B, 1 over 2 plus 3x squared. Oh, actually, I forgot to talk about validity before. Hang on. Validity. Sorry, validity. Validity. Sorry, validity. So when is this valid? So when the x over 4, so when x over 4 is less than 1, you can take a quarter out. So x has to be less than 4. That's the validity. So where does it come from? This come from here. Okay, just color code for you. That's when you think about, where's it come from? You can use the previous notes in here. You can see the b over a comes from here. Same thing. Okay, pause the video for part B. You can have a go at a question. I'll set you up if you're struggling to start. 2 plus 3x is 2 plus 3x. 2 squared. Yep. So we can rewrite as 2 plus 3x to the power of minus 2. Okay, that's where you can start factorizing 2, etc. So pause video, have a go, and the factorizing bit. See if you can, before you don't have to do the expansion yet. Okay, pause video, do the factorizing bit. Okay, check your answer with me before you do the expansion. Right? Have a go. So before applying the binomial expansion, this is the format you should be getting to. A quarter, 1 plus 3 over 2, x to the power of minus 2. Okay, so you should be writing a quarter, 1 plus 3 over 2, x to the power of minus 2, roughly equals to a quarter. Now do expansion. Pause video, have a go. When you're ready for the answer, you can press play. Here's the answer. Okay, here's the final answer. Okay, you've got it right. Well done. Okay, next thing. Okay, write the validity. Pause the video again. Write the validity. Okay, that's the validity. So you can think of modulus of x less than the b over a, or just take this down and less than that. Okay. Right. So if you want to do a quick how you think about how we can get to this result quicker. Remember, if you look at the previous one, is modulus of x less than a over b. Where does a and b come from? A and b come from the number in front and the coefficient of x. So it's the number in the front divided by coefficient of x. So in here, it's a number in front divided by coefficient of x. So x is less than, the number in the front is 4. 4 divided by 1 is 4. This one, modulus of x is less than the number in the front, which is 2, divided by the coefficient, which is 3. Okay, and that's it. Is that it? Yep. If you're happy with this, okay, let's practice the validity. Okay, pause the video, have a go at the question, the validity. When you're ready for the answer, you can press play. I know you might be struggling. So, just to make sure part A did correctly, is the modulus of x less than the number in the front, 2, over the coefficient 1. Okay, we ignore negative. Okay, so modulus of x is less than 2. It's a 1 mark or 2 mark question. That's why we have to practice it. Okay, if you're happy with this, now pause the video, finish off B, C, and D. Here are the answers, B, C, and D. Right? So it's a number in the front over the coefficient, right? So question 13, not page 13, sorry, page 13. Question 1 is a withdrawing question anyway, a past paper question. Pause video is a 8-mark question. Okay, pause video, have a go at the question. When you're ready for the answer, you can press play. So here's the answer for part A. Okay, all the way just up to x squared. Okay, so even though a lot of questions will be asking for x cubed, it's just x squared. So do not do more. Okay, it's not worth the wasting of the effort. All right. Um, and then part B, this is a slightly different question. They did give you value of x, but they told you to find the value of root 11. So we know similar question is, if you remember what I taught you in chapter 4.1, the previous video, we write this type of question by rewriting the question and the approximate answer. So the whole answer in part A. And then they want root 11. So this time they want root 11. If you see, the both of them have square root. So look for common common differences. The common thing is they both square root. That means there's nothing to do with it. The difference is what's inside. 9 plus 8x and 11. So we want to make them equal, and you find x equals a quarter. So once you find x equals a quarter, we sub into right hand side, and you get 179 over 54. And I believe that's the end of 4.2.